going to start recording there. All right, well, let's have a prayer as we begin. Dear Heavenly Father, we thank you for your abundant blessings. We thank you for this day that you have given and for your wonderful mercies. We ask for you to draw us close to you. As we have the opportunity of covering this topic, we ask for you to bless abundantly and to work mightily and to teach us things that we need to know. This we pray in Jesus' name. Amen. All right, the topic of the hour is cancer. And we're going to be looking at reversing cancer and getting into that topic and hopefully understanding cancer a little bit better while we go through this. First of all, cancer is not just a single disease. It's actually a collection of related diseases. And those diseases all have the same type of manifestations, where you have some body cells that begin to divide without stopping. So here at the top, you see this is kind of an artist's depiction of what a normal line of cells would be like. And then here, instead of having that normal cell line, now you had somebody that started growing and producing too many, but still they're in a line. They're not so jumbled and disorganized. Here, well, they start getting more jumbled and disorganized and bigger and so on, and then eventually break loose and go to different places. Well, it's a good depiction, shows us kind of the progression of what cancer is like. So some body cells begin to divide without stopping, and they can start spreading into the surrounding tissues. And that's common features with any cancer. Cancer can start anywhere in the body. Any tissue can develop cancer. It's not often that certain tissues are affected, meaning there are some tissues that seem to be fairly protected from cancer. For example, the eyes. Not often that you have cancer that develops in the eyes, but it can happen. And it's not often that you actually have cancer that develops in the heart muscle, but it can happen as well. But other tissues tend to be much more involved in cancer, like breast, prostate, lung, colon, other places like that. So normally what happens, cells will grow, they will grow in size, and then they'll separate and divide, and they will fill up a space that they have available for them. And so the environment for it around them kind of determines how big they're going to get. Almost like if you put a lot of fish, if you put them in a certain size tank, they're going to stay a size that matches with that tank. Not always, that's not always the case, but that's frequently the case. And the same thing is here with normal cells, but with cancer cells, it's like those fish that you put in a tank, and regardless of what the size of the tank is, the fish continues to get bigger and bigger, eventually too big for its tank. Well, the same thing happens with the cancer. It begins to grow and divide, and it doesn't stop when it's supposed to. Normal cells, they, at least within our context since the fall, normal cells have this process where they eventually die, and the cancer cells tend to survive when they should be turned off, when they should be dying. And new cells will form when they're not needed, whereas with regular cells, it holds off on producing new cells when it's not needed. And those cancer cells, again, will divide without stopping. This is a nice little diagram. It shows us, gives us an idea. We're going to compare normal myeloid progenitor cells. These are basically stem cells of the immune system, white blood cells, stem cells in the immune system. And we're going to show, it shows here that there's one progenitor cell, one parent cell. And let's say that this is it's a B lymphocyte or it's a T lymphocyte. Let's say that you had a particular virus or bacteria that was identified in the system, and now you have this particular guy that can identify that particular bug or that particular bad guy, and it's going to start ramping up its growth process. So it's going to start growing quickly, it's going to start dividing, and it's going to start producing more and more children. And those children are going to do the same thing and continue dividing. And so very quickly, you can go from one cell, and if this is your first exposure to that particular agent, bacteria, virus, or whatever it is, then in 7 days, you can have up to 10,000 of those cells. That's a lot of replication that happens really fast. 1 to 10,000 in just 7 days. But in that same period of time, if you have a cell, a white blood cell that turns cancerous, and this is now representing leukemia or leukemic cell, you have one of those. In 7 days, you might just end up with 2 children, or maybe 3 daughter cells, right? 2 or 3 daughter cells that you'll have at the end of a week. Whereas here, you're going to have 10,000 at the end of a week. So it doesn't seem like cancer is so bad, and this process might even be worse, but you need this process in order to fight the infection and get it under control. You've got to be able to ramp up the immune system and its function in order to be able to take care of this. But what happens? Where's the bad part? It comes next. The bad part is, as far as the cancer is concerned, here you have all of these 10,000 cells. Now you don't need them. The infection is taken care of. Well, there are signals that tell these cells to die. And the vast majority of them will listen to those signals, will respond to the signals, and they will die. And some of them will remain. A few of them will remain to be memory cells, so that if you come in contact with this thing again in the future, you can mount a quicker response to it and not have to get so sick with it. But over here with your leukemic cells, they don't respond to that signal. So you have this signal that tells these cells to go ahead and die. They'll receive that signal and they'll go ahead and die. But that signal here, the leukemic cell doesn't get it. And so instead of all these guys dying away, now you've got those 2 to 3 from 1 week. Those 2 to 3 end up being, 4 to 6 the next week, and so on and so forth. It might not be that slow, or it might be slower, just depending on the cancer as far as the growth is concerned. What is a tumor that is malignant? Well, again, you have cancerous tumors that are malignant. You can have benign tumors that are benign, that are not malignant. The ones that are benign are ones that do not invade tissue that's around them. So here you have an example, again, another artist's rendition of what cancer kind of looks like. You have a normal line of cells. These are epithelial cells lining some kind of lining, whether it's respiratory tract, digestive tract, skin, or whatever it might be. Let's just say it's the way that it looks it's digestive. I'll just say that it's digestive. And so you have a mutation that occurs in one of these cells, and then it starts growing and not following the rules. And so it starts growing, and instead of stopping in its growth, it's going to continue its growth. Then it's going to pick up more mutations, and it stops looking like its normal cells. It's going to continue, and it's going to start growing into the surrounding tissues near it, and it will continue doing so, invading into the tissues around it, and then maybe growing into blood vessels, lymph nodes, and spreading to other places. So when you have a cancer that stays in its place, it might grow right here and get bigger and bigger and bigger, but it doesn't invade into the tissue that's next to it, or actually that might be the open space. So the tissue down here, it doesn't invade down into the tissue. It just grows in its space and gets bigger and bigger and bigger and bigger. Well, those benign tumors are less likely to kill you because they're not going to go and spread somewhere else. And indeed, you can cut them out, and if you get everything, well, that's great. They're probably not going to grow back. If you miss a little bit, well, then that part's going to grow back in the same place, and then you can go back and cut it out again. But here you have this one invading the tissues. The benign tumor does not do that. Malignant tumors do, and they can spread into or invade nearby tissues. And metastatic, that means that the cancer cells have broken off and they've traveled to distant places, typically through the lymph vessels or through the blood vessels. And so it's not just local growth in its area, but it's getting off into other bloodstream or other fluid flow and moving to a separate location in order to grow. Cancer cells are less specialized than normal cells of the body. Normal cells tend to be very distinct. If you have a pathologist or a microbiologist that is familiar with the various different cells in the body, you can give them normal cells, put it under a microscope, and identify quite clearly what those things are by looking at them, because they have very distinct features about them. But when it comes to cancer cells, it becomes very difficult to identify what it is unless the pathologist knows where you took the sample from. And even then, they have to do a lot of testing and stains and other types of like antibody testing and stuff in order to figure out what the thing actually is. So cancer cells are not very distinct. They tend to have less specific functions, and there's differences in how they look. So cancer cells tend to be large, and they have abnormally or large variation in the shapes and sizes of their nucleus. They're going to have more dividing cells, disorganized arrangement. They tend to have a variation in their size and shape, and they lose their nice natural features that you normally have with regular cells. And so it's visual evidence of the dysregulation that's going on in the genes in the cells. So cancer cells ignore signals that tell them to stop dividing or to die. Stop signs are good things. Stop lights are good things. If you don't pay attention to the stop signs, then things like this happen. And indeed, from a health standpoint, that's what happens when cancer gets involved. And those cells do not stop dividing, or they don't die when they are supposed to. And cancer cells, they're able to produce hormones, and they're able to influence cells and tissues that are around them. And indeed, there is this growth of blood vessels called angiogenesis. Here's the idea. Here you have the tumor. It's releasing chemicals in the environment. Those chemicals cause the blood vessels to grow up to this area. Here you have that depiction. So the blood vessels are growing up to the area so that it can supply the nutrients that are needed in order for those cells to continue to divide and to divide rapidly and to grow. Of course, one of the ways that you can look at trying to kill cancer in a particular location is to try to cut off all of that blood flow so that it's decreased. And in fact, that's one of the interventions sometimes that is offered when there are tumors in specific locations where you can't go in and do surgery. Sometimes interventional radiology will go in and they'll take a catheter and they'll put it up the artery that's going to that area, squirt dye in there, do x-rays, see where the blood vessel stuff is, and then basically deposit some goo or coils or other things in the area to stop the blood flow there and basically starve the tumor. And it can help for a while, just like surgery can help for a while. Cancer cells can hide from the immune system. The immune system, the immune cells, they go around, they cannot see what's going on the inside of cells. So they don't know what's going on in the nucleus. They don't know what's going on. The only way they know what's going on in the cells is that cells have this function where many cells will take things from the inside of them and put them on the outside on the surface and basically hold it out there. And those things they hold on the outside, proteins and so on, gives the immune system an idea of, is this guy is me, or if it's not me, right? Is it self or is it not self? And so there are certain proteins or cell pieces that get put out there on the surface that can alert the immune system that there's a problem in here and this might be a cancer cell. Well, cancer cells have certain functions that can happen in them so that they don't present those things well, so that the immune system doesn't even know that it's there or that it's bad or it's a problem. And even some tumors can kind of hijack the immune system to stay alive and to grow, and actually use it to grow. Quite insidious. And then, of course, the cancer cells can keep immune cells from killing them, mainly by keeping them from being able to recognize that it is a cancer cell. Now, we do know that cancer is a genetic disease. Not inherited like we talked about in the law of life, but genetic, right? So there's a mutation that happens in the DNA. Here's the DNA, the double helix, and this is indicating that there's a wrong letter that was inserted in here, or a problem associated with that. So yes, definitely, cancer is a genetic disease, and it's the result of changes in genes which control how cells function, how they grow, how they divide, or how they die. So if you have a, let me see, all right, let's go here. So if you have a gene that controls how the cells function, how much activity that they're going to have, and there's a mutation in that cell that does not allow the cell to slow down and just continues at high function. It's almost like getting the gas pedal on the car stuck and you can't turn it off. That could be a problem. If there is a mutation so that the baby doesn't stop growing, and so the baby gets bigger and bigger and bigger and bigger and bigger and bigger, that's a problem too. If there are genes that are supposed to help regulate when the cells divide, how quickly they divide, and so on, and that gets misregulated, if there's a mutation that happens there, well, then cells get out of control as far as that's concerned. And then, of course, if you're supposed to respond to signals to die, but the DNA that is responsible for coding those signals is messed up, well, you're not going to die when you're supposed to. And these mutations can develop during your lifetime because of damage to the DNA. And damage comes sometimes because of substances. You can have oxygen-free radicals. Oxygen-free radicals are the things that antioxidants take care of. Okay? And oxygen-free radicals can cause damage to molecules in the body, and if they get in around the DNA, then they can cause damage to the DNA. Or you can have radiation, ionizing radiation like X-ray, gamma rays, and other things like that, or ultraviolet radiation over a long period of time. That can damage DNA, and if the DNA repair mechanism gets messed up or is overwhelmed, then you can have some more permanent and concerning dysfunction, including the development of cancer. Now, here are some examples of genetic mutations. So we're going to take this original sentence, time to dream. And every space is going to stay the same. First word's going to have 3 letters, next one's going to have 2, and the next one's going to have, well, at least 5. You'll fill it up in a row. And here you have a single letter change. So instead of saying time to dream, we're going to say tame to dream. It's the same number of letters in each one. It's almost the same sequence, but it's an entirely different meaning. Tame to dream is different than time to dream. So it might make sense, sort of, time to dream means that it's time right now. Tame to dream would mean, okay, well, you have to get something under control before you get a dream, I guess. You can reverse the order. So instead of time to dream, you can do E-M-I-T, emit to dream. That one, okay, so it gets more, now you're like, what does that really mean? Now you have a deletion where you take I-M out, but you're still filling in 4 letters here, so you lose those, so you're going tet, to, trim, im. Now that doesn't make any sense. And then you just insert an insertion, insert another I in there, so it's tem, et, odrim, right? So you can see, you can either substitute one letter for another that was wrong, you can turn them backwards, you can take something out, or you can put something in, and all of that can mess up the meaning of the letters, of the sentences, and so on, and it can mess up the DNA or the genes that code for something. Now, you can also have problems when it comes to the epigenome. because the DNA, the genetic material, and that which is passed on from cell to cell and parent to child and so on, is not just the DNA. It's not just the letter sequence of the DNA molecule. It's also molecular tags that get added to the DNA that have a particular function. For example, these little tags, these methyl groups, methyl group is a carbon with 3 hydrogens attached to it, and then the last bond for the carbon that's available attaches to here the DNA strand. And you have methyl groups. The more methyl groups you have, the tighter the DNA winds around these histones, kind of barrels that the DNA winds around. So if you have a gene in here, it's not as available to get to as if it was around here. And so there's acetyl groups, methyl groups, there's some other tags that can be put on DNA. And by changing the density and the amount of tags, or changing where they're at, you can change how the DNA behaves. You can upregulate or downregulate, turn on or turn off particular genes that are there. And that's actually a very good thing, because that's how lifestyle works. How does lifestyle help in reversing cancer? It's not that it undoes the mutations. The mutations are there, but it helps to turn down or turn off the regulation, the expression of those genes, and it improves the immune system's function so the immune system can take care of it. Each cancer has a unique combination of genetic changes or mutations in it. And as the cancer grows, it accumulates more and more mutations. And so the cancer, by the time it's fully mature, will have many more mutations in it than it did at the very beginning. And different cells within a tumor may have different genetic changes, might have different mutations in them, just depending on how things are going along in this process. And cancer cells usually have more mutations than normal cells. Normal cells will have mutations too. What makes the difference between a normal cell with mutations and a cancerous cell with mutations? Well, again, the cancerous cells, the mutations are in those genes that are responsible for cell division, for cell death, for the activity of the cell function, and so on and so forth. And the mutations that might be in normal cells might be a mutation in an area that's hardly ever used. Not very active. You have proto-oncogenes. These are involved. These are genes that are involved in normal cell growth and normal division. When they become mutated, then they turn into oncogenes. Oncogenes means cancer-causing genes. You have tumor suppressor genes. You have genes that are there to suppress abnormal growth or replication of cells. And those are involved in controlling cell growth and division, but when they get altered, then your cells divide uncontrollably. And then you have DNA repair genes. Every time you reproduce one cell to the next, and you have to basically transcribe all of that DNA code, billions of letters of DNA. And it's not mistake-free, but there are molecules that go along and do proofreading and fix errors and other things like that along the way. Well, if they get altered, then the cells don't get repaired very well, and they will develop more and more mutations faster if those repair molecules are damaged. In the United States, the risk of developing cancer is associated with the age of the individual. When we look at gender, men have about 1 in 2, 43% risk of developing cancer during their lifetime. Women, around 22.8, or 1 in 4. So men are going to develop cancer much more often than women are from a lifetime standpoint. Risk of developing it is 43, and risk of dying from it is 22%. Females are going to be less. They're about 37, almost 38% risk of developing it during their lifetime, and about 19% risk of dying from it in their lifetime. These numbers are increasing. I think this is from a few years ago, and indeed cancer is growing. The amount of it is growing in the United States. I think we're going to cover that in a bit, so I'll zip my lip until we get there about those details. As far as age is concerned, your risk of developing cancer, if you're in the United States, and you're in the 50s, you only have a 1 in 20 chance of or risk of developing cancer if you're in your 50s. If you're in your 60s, you have a 1 in 10 risk. That's 10 times as much. If you're in your 70s, you have a 1 in 5 risk. That's another 10 times the risk. And then if you're in your 80s, you have a 1 in 3. So about 33% of individuals in their 80s will develop some form of cancer. So as you age, that DNAs and those cells have been around longer, been exposed to a lot of different things like radiation and oxygen-free radicals and so on and so forth. And the immune system is not working as well, especially as you get elderly. So all of those come together. Here we go. All right, so cancer is a growing problem in the United States. In 2002, there were only 2 states in the United States that had more death from cancer than they had from cardiovascular disease. Now, cardiovascular disease has been the #1 killer for decades, and it's the #1 killer really around the world. But in 2014, 22 states had cancer deaths more than cardiovascular disease death. And so we expect that within the next 5 years, maybe 10 years, cancer is going to become the #1 leading cause of death in the United States, and will rapidly progress that way across the world because the world is copying the United States in how we eat and live and so on. So there's a lot of bad stuff that U.S. Exports, like McDonald's and Burger King and other things like that. So of the population, not only do you have an increasing amount of cancer because there's more people in the population and there's more cancer developing, but remember, the older you get, the more cancer an individual tends to develop as well, and our populations are aging. The number or the percentage of individuals that were 65 or older in the population, Europe, back in 1960, it was only 10.6%. Now, 21%. US, it was 9.2, now it's 15.9, and worldwide it was 5.3, now it's 9.4. So our populations are getting older, and because they're getting older, then there's higher rates of cancer that are developing in the populations. What are some risk factors for developing cancer? Well, one is age. And again, the older you get, the more risk you have of developing cancer. Alcohol intake, alcohol. And you say, well, I thought I'm supposed to drink, 1 or 2 glasses of wine a night in order to help me with cardiovascular disease, or a day to help me with cardiovascular disease. Well, yes, with wine, it's shown that there is benefit for the men. There is heart benefit from the women, but the same amount of alcohol that you drink that gives you heart benefit for the women doubles your risk for breast cancer. And there's all sorts of cancers that are associated with alcohol intake as well. We're going to cover that a little bit more in depth later in this presentation. Alcohol is not good for you. What is the good part of the wine? It's the grapes, the resveratrol from the grapes. And so if you want the benefit of the wine, drink a glass or 2 glasses of Welch's grape juice every day rather than the other. In fact, there is research that shows that if you drink, the whole grape juice like that, not just grape flavored drinks, but the whole grape juice like that, there is cardiovascular benefit, and there's probably cancer benefit too. There are cancer-causing substances that you come in contact with that can cause cancer, like asbestos, right? Chronic inflammation, so if you have an inflammatory process that stays in place for a long time, that can cause cancer. Dietary factors, we know that processed red meats is a class 1 carcinogen, classified that way by the World Health Organization. Red meats are very close to that as far as their risk. And so the more meat in the diet, the more cancer that individuals develop, and so on. Hormones, so you can have hormonal imbalances that can lead to the development of cancer. Immunosuppression, so you might be on steroid medications or other things, or immunosuppressed because of chemotherapy related to cancer that you already have, and then develop more cancer from it. Infectious agents, so there are viruses that can cause cancer, like the cause for cervical cancer in women is HPV, human papilloma virus. And so that's an infectious agent that can lead to the development of cancer. Obesity, there's at least 11 or is it 14 now cancers that have been shown to be associated with obesity, radiation exposure, too much sunlight, tobacco, and so on. So our conventional treatments are things like radiation, surgery, chemotherapy, and then targeted drug therapies. These are trying to get more and more accurate. Rather than just being generalized, kind of poisoning the system, they're getting more and more accurate with these things. Not without side effects, though. So what happens with a cell, with a tumor? And we look at the growth of a tumor here. Biological and clinical correlates of tumor growth. So I'll just explain this to you. Here we have the beginning of the cancer growth where you have no cells. Right? So here's the number of cells. 10 to the 0 is, well, 0. Here you have 10 to the 3rd, which is 1,000. Here you have 10 to the 6th, which is a million, billion, trillion. All right. So that's how many cells that there are. This is how much approximately that the tumor weighs, microgram, milligram, gram, and kilogram. And then here is the number of times that the cells have doubled. And then what it looks like and what's happening from a clinical standpoint. So when you start off at 0 and then you have your first mutation and then you start going, well, the growth rate actually, this curve is a little bit deceptive. The growth rate is actually probably running along like this, where it's very little growth and then it starts growing and then it starts taking off and then it starts taking off like this. That's really what the growth curve would look like. Now this is a growth rate instead of the actual numbers. But this tells us that as it's growing, it's going to take a while actually to get to here. This is where your exponential growth phase goes. Once you get around 1,000 cells, then it starts really taking off. It takes about 1 million cells before you start developing neovascularization or angiogenesis, where you're growing blood vessels to the tumor to help its growth. You can imagine by the time you have 1 million cells, you're going to need some additional blood vessels there to provide the nutrients for it to be able to survive. But it takes about 1 billion cells, about 1 billion cells together in one spot for us to be able to even discover the things there. So you can have cancer going on for quite a while before it ever gets to the point where you can discover it, because it's just too small. We can't see it, right? And then about another, you go from 1 billion to 1 trillion. Well, that's about the time that the cancer will kill somebody, because it's taking so much of the metabolic energy, it's taking so much of the glucose and everything, and life is not possible for the host and the cancer at the same time. Now, this line right here, where you have clinical detection, where you're able to discover that, okay, ooh, here's a tumor. There's something that happens, when we have cancer therapy, we talk about remission and then we talk about relapse. Well, what is that about? Well, if you have 1 billion cells here, and you finally discover that there's the lump in the breast, right? You discover that it's there. Do a mammogram, ultrasound, maybe an MRI, classify it, and so on, and you decide to go ahead and do chemotherapy. And so you do chemotherapy in the area. Usually they do radiation, but sometimes they'll do radiation first. I mean, they do surgery, but they'll do chemotherapy first sometimes to shrink the size of the tumor. Well, let's say that they do that and they shrink it and it goes away and they can't even find it anymore. Maybe you were over here and you were at 10 to the 10th. That might be a little bit vague, but and the chemotherapy knocked it down, so, well, they can't find it anymore. They say, okay, well, we don't have to do surgery because, there's no tumor to do surgery on. The chemotherapy worked, you're in remission. Well, you still could have 1 million, 10 million, 100 million cells of cancer in your body, and it's just not big enough for us to see. And so let's say that if it did that and it knocked it down to 100 million cells and you can't see it anymore, they say, well, hey, it worked. You're you're in remission, cancer remission. Well, if those 100 million grow and grow and grow and eventually get back to 1 billion and so on, then it finally, you can find it again, and then they say, oh, well, your cancer has come back. It's relapsed. But it never went away. It never was treated completely. You never went back down to 0. It just was in this range where we couldn't find it. And that's basically the same thing saying there. All right, so what are some things that we can do for cancer? Now we understand a little bit about cancer and how it grows and its detection and so on. So one big overview as far as cancer is concerned is if you don't want cancer, or if you want to survive your cancer, eat a lot of fruits and vegetables. That's a big message out there. You hear it in all the cancer societies. They're finally playing that, they're finally playing that tune. Now we've been advocating that for a long time, and it's been a long time before people are coming around to this, but it's true. More fruits and more vegetables, it's going to protect you against cancers. Specifically, we know that it will decrease the rates of mouth, throat, voice box, esophageal, your swallowing tube, stomach, lung, pancreas, and prostate cancers, amongst many others. Pretty much every cancer line, the more fruits and the more vegetables that you consume, the less risk that you're going to have of developing cancer, and the more you will survive that cancer. Remember, one of the things that leads to cancer is those oxygen-free radicals that you come into contact with all the time. And the thing that helps the oxygen-free radicals are antioxidants, and your fruits and vegetables tend to be pretty high in antioxidants. And for your fruits, if you really want to be high in your antioxidants, eat a lot of berries. They're pretty good. So you have plant phytochemicals. Those phytochemicals also help to regulate hormones. And again, hormones play into cancer growth and so on. These phytochemicals can slow cancer growth, can reduce inflammation, and can reduce oxidative damage, all of those things that are known to be promoters of cancer and cancer growth. So fruits and vegetables, score, right? And they taste pretty good. And if they don't taste pretty good, that means you're eating some bad stuff. And that bad stuff is changing your taste buds so that you don't like the fruits and vegetables. Of vegetables, one group that's particularly beneficial is cruciferous vegetables. That includes things like your broccoli and Brussels sprouts and cabbage and kohlrabi and oh my, what's the white stuff? Cauliflower, thank you. And bok choy, kale, and so on. All of these are cruciferous vegetables, and they're particularly beneficial when it comes to cancer and their anti-cancer effect. Research shows reducing the risks of mouth cancer, pharynx, voice box, esophagus, stomach cancers. They also help to regulate body enzymes that defend against cancer, and they can stop some cancer cell growths in certain studies. So it's something that's good to have in part of your anti-cancer routine or survive cancer routine. Although I will say this right now, there is research out there showing that you do not want to do high antioxidants while you are doing chemotherapy. So if you are doing chemotherapy, cut out the juicing, cut out the extra fruits and vegetables and other things like that. I know you're probably saying, whoa, hang on. You mean I'm not supposed to eat healthy while I'm doing chemotherapy? Apparently the answer is no. Right? Apparently the answer is no, because if you're not eating healthy, I don't mean go out and eat all potato chips and French fries and sugary products and other things like that. But the more antioxidants you eat, the antioxidants protect not just your regular cells, but your cancer cells as well from the chemotherapy. So what's the solution to all of that? Well, yeah, you gotta think about what we're doing. All right, lycopene. Lycopene is found in various fruits and vegetables. So tomatoes are a very big source of lycopene, but it's also found in pink grapefruit and watermelons and apricots. It's what makes the reddish orange color in them. And lycopene has been shown to be beneficial when it comes to lung cancer, stomach, prostate, colon, mouth, and esophageal cancer. Prostate, trying to remember if it was Loma Linda or if it was Harvard that came out with the study that found that prostate cancer was lower in those that had higher tomato product intake. Well, anyways, then a study was done, and I think this was from Harvard, and Harvard did a study on lycopene supplements to see, you know, if individuals were more likely to develop cancer, less likely, and so on with taking lycopene. They thought more lycopene, less prostate cancer. That's what they were thinking. And so they enrolled a whole bunch of gentlemen in a trial, and half the group were getting placebo, the other half were getting the lycopene. And they had to stop the trial after 2.5 years because the lycopene group had higher rates of prostate cancer, significantly higher. And so that they were actually causing more cancer with lycopene supplementation. So even though we identified, oh, well, we think lycopene is good, it's actually the product as God made it. It's the tomato that's good, not just the single product or lycopene out of it. So eat whole, right? Eat whole. Don't just turn yourself into some kind of supplement factory, right? Soy, oh, soy and cancer. Whoa, that's a topic if there isn't a topic out there, right? So we have edamame, we've got regular soybeans. This is, of course, well, edamame in the pod. You've got tofu, you've got soy milk that's here. What's the story on soy? Well, soy is actually good for breast cancer. It's good for ovarian cancer. It's good for a bunch of different cancers. I just put these on here because those are the questionable ones. But a bunch of cancers, soy is actually good for. Why? There are a number of things that happens with soy. Soy has some excellent phytonutrients in them. It is true that, you know, we say that, oh, it has plant phytoestrogens like genistein and so on. But the reality is that those do not act like regular estrogen stimulators. In fact, we found that breast tissue does not just have an estrogen receptor, it has at least 2 estrogen receptors, an alpha and a beta. And the alpha, stimulated by your body's own production of estrogen, plus any exogenous estrogen like estrogen patches, estrogen shots, estrogen pills, and so on. And that is related, hormones related to breast cancer development or growth. But soy actually stimulates the beta receptor, the beta estrogen receptor, and that actually downregulates growth of the breast cancer. But it also stimulates beta estrogen receptors in the bone marrow, which actually in the bone, which increases bone mineral density. And so the more soy intake, the less osteoporosis that an individual has, less breast cancer that they develop. In fact, the research shows that those have more soy intake have less breast cancer, survive breast cancer better, and it's good overall for breast cancer. There's a number of studies from that standpoint. Hang on, what about the dissent? What about the other studies that show that it's bad? Well, it depends on the source that you're getting it from. Here we're talking about whole soy products, and yes, tofu is still considered a whole soy product, so go for it. But we're looking at whole soy products, and soy milk is too. It's actually the milk alternative that has the best research for health overall is soy milk. I like almond milk better, but soy milk has the better research. Oh, what was I saying? We were talking about cancer, and yes. Okay, so so the soy research shows that there is an epigenetic change in the cancer tissues to help downregulate the genes, the cancer-associated genes, in those that are consuming more soy products, whole soy products. Those that have negative effects associated with soy intake are eating highly processed soy products. Textured vegetable protein, hydrolyzed soy protein isolates, other things like that. You can make plastic out of soybeans. And nobody's going to argue that plastic is a health food. It's not, right? So you can process soy to the point where it becomes unhealthy for you. And yes, that processed soy can promote cancer. So you want to stick with whole soy products rather than processed soy products. The other vegetable family that is actually top of the line as far as vegetables are concerned with their anti-cancer effect is your allium vegetables. And these are wonderful things like garlic. Garlic is #1 on the vegetable list. Onions, leeks, chives, scallions, and so on. This group of vegetables, these are #1 on the list for your anti-cancer properties associated with them. In fact, in one study looking at 25 different vegetables associated with 9 different cancer lines, garlic was #1 out of all of those vegetables on 8 of the 9, and on the last one that it wasn't #1, it was #2, and leeks were #1 on that one. So allium rules from that standpoint. They have these allyl sulfides, flavonoids, and quercetin. Quercetin particularly high in your onions that help to inhibit mutation, right? Mutagenesis. They modulate your enzyme activity. They inhibit DNA adduct formation, meaning damage or alteration in the DNA. And they scavenge free radicals, so they're great antioxidants, and they affect how the cells will grow and proliferate. So it's really good. So what do highly refined foods, meats, including fish, and eggs and dairy have in common? Well, they are all, and fried foods too. These have in common as well. These all are big sources of oxygen-free radicals. What's an oxygen-free radical? Well, it's a molecule. Let's go back to chemistry class, Chemistry 101. Which I don't think it was 101, that was just literature, right? So your molecules, your atoms, they have these electron shields around them, right? This electron cloud, actually, that's around them. And those electron clouds like to be stable. And so this first shell likes to have 2 electrons in it. The next shell out layer wants to have 8 electrons in it. The other one, next one out after it, I think was it 16? Then 32, and so on. So they want to have that full. But if they're missing one, if they're missing electron, then they're hungry for electrons. They want to steal it from somewhere else. Or if they have an extra one floating out here, they want to give that one away. Now, these ones that have a missing electron or an additional one that they want to give away, those are free radicals. They're unstable from an electrical standpoint, and they want to be stabilized. And so these guys go bumping around and bumping into other things, and they will steal electrons from other ones, making them a bit more radical themselves and unstable. And when it does it to DNA, well, DNA is more subject to mutation. So how can you help that with nutrition? Well, you want to eat whole plant foods because they're high in antioxidants, and antioxidants are substances, molecules that can come up against an oxygen-free radical, can either take away one of its electrons or give it an electron and not be damaged itself. And so it ends up stabilizing the oxygen-free radical and itself remaining stable. And so from a nutrition plan standpoint, eat foods and eat it whole. Eat plant foods whole. You know, a variety of colors is great. Get it as fresh as you can. Buy it and get it when it looks like how it grows. That's the best way of having it. I said 80% raw. There is no magic figure. That's just, not, put your finger in the air and say, okay, well, what percentage? There is no number, I think, that could say, okay, well, this percent or that percent. You just want to make sure that you have a good portion of your diet that is raw and another portion of it that's cooked. Eat a variety of colors. Avoid animals and their byproducts. Avoid dairy and eggs. Avoid processed carbohydrates, sugars, high fatty foods, and so on. You want to avoid all of those things because those are all the things that tend to promote cancer and poor immune function. Exercise is also a treatment for cancer. We know that increased physical activity decreases your risk of developing cancer, and it also increases your risk of surviving from cancer. Those that are the most physically fit of different groups that have been studied, they have about half the chance of developing colon cancer than those that are unfit. about 40% less chance of developing breast cancer, less chance of developing uterine or lung cancer, and more than half or less than half the risk of developing pancreatic cancer. So that's pretty cool, and almost a quarter of the risk of developing prostate cancer compared to those that are sedentary and unfit. So you can significantly reduce your risk of developing any of these cancers just by staying fit. Go out and walk every day, take a jog, go swimming, ride a bike, do heavy gardening and other things like that. And if you do have cancer, you can decrease your risk of dying from breast cancer up to 40% by increasing your physical activity. So it's definitely good to prevent you from developing cancer, but also to treat you if you have the cancer. What about sunshine? Sunshine, good thing, bad? What's the news on sunshine? Oh, let me go back to that. Well, the answer is it's good. Sunshine is good. God created you for sunshine, and you should be eating. Eating. You should be. Sorry, let me just do that. You should be getting your sunshine exposure. Well, the dermatologist says that I should stay out of the sunshine. Well, there are certain medications that you can be on that could make it bad. And there are certain conditions to lupus, like systemic lupus erythematosus. Sometimes people can't tolerate being in the sunlight because it stimulates the lupus flare-up, and so on. But for the most part, we should be out there and getting our sunshine. Why? Well, it's true that we can have cancer development with sun exposure, especially if we burn ourselves or we have frequent sun exposure with light skin over a long period of time. But mostly burning is the thing that's a risk factor. So you don't want to burn, but you don't want to get sunshine exposure on a regular basis. Why? You need vitamin D. Vitamin D is helpful. It is very good. In fact, individuals that are vitamin D deficient are more likely to develop cancer than those that are not. And it helps with immune function too. And so there's recommendations about having good vitamin D levels in the midst of this whole coronavirus craze and so on. Getting that vitamin D. One study was looking at the effect of increased sun exposure when it came to the risk of dying from skin cancer versus the other diseases that individuals would stop dying from if they had sufficient vitamin D levels. And so if we went out in the sunshine and got sufficient sun exposure to have our vitamin D levels normal and reduce all of these diseases like cardiovascular disease, cancer, diabetes, obesity, and so on, asthma and Alzheimer's and other ones that are associated with low vitamin D levels. Multiple sclerosis, there are a lot of them. Anyways, if we got out in the sunshine and got enough sunshine exposure to reverse our vitamin D levels, for every one person that died from skin cancer because of the increased exposure, 99 people would not die from the other diseases that they would have if they had low vitamin D levels. So there's a significant health benefit associated with having sufficient vitamin D levels and getting your sunshine on a regular basis. But again, be smart about it. Don't burn. Don't use oils and creams and other things like that on your skin. That can increase your risk of developing cancer with sun exposure. Tobacco, bad for you. 30% of all cancer deaths are related to cancer. Tobacco, 80% of all lung cancer deaths. It's just not a good thing. And it's not just where the smoke goes, but your mouth, your larynx, your pharynx, your esophagus, kidney, cervix, bladder, liver, pancreas, stomach, colon, rectum. All of those cancers are associated with smoking and tobacco exposure. So not a good thing. Oh, and leukemia too. So don't do it. Alcohol, again, all types of alcohol can cause cancer. Ethanol, acetaldehyde, estrogen, and so on. You can have head, neck, liver, esophagus, breast, colon, rectum, and stomach cancers. Ethanol promotes the development of estrogens, and especially if we're talking beer, because hops beer is typically made from hops. Hops is an estrogen stimulator. And so individuals that pick the hops plant for beer they tend to have much higher rates of breast cancer, just the pickers, even if they don't drink the alcohol, because they're coming into exposure with those estrogen stimulating substances of the plant. There are all sorts of toxins associated with, that can cause cancer that you want to avoid, like acetaldehyde, aflatoxins, asbestos, azathioprine, benzene, cadmium, coal, diesel exhaust, formaldehyde. There are infections that can cause cancer, like HIV, human papillomavirus, human T-cell lymphoma virus, HHV8. You've got air pollution, radon, silica dust, trichloroethylene, vinyl chloride, and all sorts of things that are out there that can cause cancer. Try to live in a clean, natural environment. Now, there are certain herbs that are beneficial for cancer that have been shown in the research. One of those is sweet wormwood, also called Artemisia annua or sweet Annie. Those are some names for Artemisia. Comes from Asian locations, India, Pakistan, those locations, has been used for many years to treat malaria and does a fair job at treating malaria, but it also has anti-cancer properties to it as well. And so that's one of the ones that we use here at our lifestyle center. Turmeric, that good yummy yellow stuff. What's better, the powder or the root? Actually, the root is probably going to be better for you because it's fresher. The fresher it is, usually the better it is for you. And consuming a sufficient amount. A lot of people have access to the powder and the turmeric, so we recommend at least a teaspoon a day in the diet. It's very anti-inflammatory, helps with pain, and there is anti-cancer potential to it. Some studies show you can even put it topically, like if skin cancer or a superficial cancer or something like that, then putting it topically on that area. So that can be helpful or beneficial. All right, and then we will get to your questions at the end here. Red clover, it's another one that has benefit for a number of different cancers. It's basically known as a blood purifier, found everywhere, one of those yummy tasting teas, so not really hard to take, and it can be beneficial as well. Black cumin seed, this one, you see the seed right there. You don't want to eat it just like that. You want to grind it up because the effective part is on the inside, and you're not going to get much of it if it's all together in its whole like that. So you need to grind it up like you would flaxseed. And black cumin has been shown to be beneficial with a number of different cancer cell lines. That's about a teaspoon of freshly ground black cumin seed on a daily basis. That's what's been seen in studies. You could probably tolerate more than that, but that's what the studies have shown, and there's some good benefit associated with it. Another one that's not so yummy, at least for most individuals, some people tolerate it just fine, but that is our good old-fashioned aloe. Aloe. It has some anti-cancer potential as well. If you're making your own aloe or using your own aloe, take a knife and cut off those spines on each side, all right? And if you want to have diarrhea or loose bowels with it, then just leave it all together with the gel and the skin and blend it up in the blender and then take it that way. If you don't want the diarrhea or loose bowels, then you cut the skin off and you scoop out the gel from the inside and you use the gel. And again, it has anti-cancer potential. How much do you have? It just depends. We'll usually do about a third of a cup 3 times a day. The aloe helps also with digestive tract, with gastroesophageal reflux disease, gastritis, other digestive problems too. Quite helpful. Also, research has shown that shiitake and maitake mushrooms are also beneficial for cancer. They have some phytonutrients in them that are beneficial with fighting the cancer. And so, that it doesn't have to be raw. I don't know. Anybody eat mushrooms raw? If you do, I'm sorry. I can't stand mushrooms. So yeah, I'll be using some other things if I ever get cancer. But these can be sauteed. They can be prepared and whatever. And you're looking at about a quarter cup, third of a cup, half a cup for a day. And then you have hydrotherapy, hydrothermal therapy. This is really good stuff, hydrothermal therapy. One of the main things that we have found and research has shown associated with water treatments is to give somebody a fever and to increase their temperature. And there are a number of things that happens with that fever or that temperature. Oh, you might recognize those people. There's Ashwin and there's Adan. You know, doing treatments on each other. Anyway, so you might, there are a number of things that happens. One, with increased temperature, you can have heat shock proteins. Heat shock proteins are there to help to protect the cells from heat damage. And those heat shock proteins actually have quite a bit of interaction with the immune system. They're a very potent stimulator of immune system function. And so as your temperature goes up, those heat shock proteins start stimulating the immune system to function even better. And so tumor cells will start putting out on the surface heat shock protein 70 with heat exposure. And that heat shock protein 70 is one of those alerts to the immune system that, hey, here's a problem, take care of it, kill this cell, right? It's bad. Also, there's increased cytotoxic T lymphocytes in tumors, solid tumors, after heat treatments. And those are some of the guys that are killing the cancer. It deregulates or breaks down the blood vessel growth to the cells, and so you decrease the amount of blood flow, which is good. And it increases apoptosis, which is programmed cell death in the cancer as well. And so there's a number of benefits associated with high temperatures. How high does it need to be? Well, it depends on how much you can tolerate. In Europe, some of the studies are looking at body temperatures up to about 107, 107.2 degrees Fahrenheit. Really high temperatures, 42 Celsius. You know, really high temperatures. Real strong effects associated with it, but it depends on what you can tolerate. We try to get individuals' temperature at least up to 102. We aim for around 102 to 104, try to maintain it for at least 20, 30 minutes or so, and then bring the temperature back down, repeat that 3 to 5 times a day, 3 to 5 times a week, not a day, wow, you'd be wiped out. 3 to 5 times a week, and about 3 weeks out of every month for about 6 months or so. And we see benefit associated with it. Again, I'm not going to go in depth in this because I think we covered it a bit in the Law of Life, but that is that the nervous system has a strong impact upon cancer. Again, if you cut nerves that go to the center of a tumor, the tumor changes how it behaves. And the nervous system is involved in every step along the way of cancer's development and progression and metastasis and final triumph through its secretion or production of neurotrophins, neurotransmitters, and neuropeptides. The nervous system can control initiation of cancer and its initial growth in its location. It can control whether the cancer can survive when it gets separated from its basement membrane, which it should die, called anoikis here, but it doesn't happen, so it continues to live. The nervous system is involved in that. Changing from a very definite type of cell to an indefinite type of cell that can now get away from its location and move in different places. That is under control of the nervous system. The nervous system impacts whether these cancer cells can get out into the blood vessels and back out of the blood vessels into another location. The nervous system helps with this whole blood vessel growth out to the tumor, this angiogenesis, and it helps the immune system the cancer to evade or hide from the immune system. And it influences the environment around the tumor to improve its function and its growth. All of these things happen through the nervous system. How do we do that on a regular basis? Well, we do it through our thinking, through our attitudes, and so on. And we'll be looking again at that more this evening at 7 o'clock during the Law of Life. So what do we do? Well, there's a lot of prayer. We've got to come and ask God to help us and to give us consistency and strength and so on. He is the healer. And we've talked about a lot of different things that we can use, diet and exercise and so on, and avoiding harmful substances and other things like that. But we must recognize that none of those things can heal us. Those are just the ways that we cooperate with God in his healing process. He is the healer. He is the healer, not us. You're not the healer either. It's not your body that heals you. It is God that heals you, but God has created within you the process that he uses then to bring about that healing, the immune system and so on. And so as we cooperate with him by faith in what he has done and the things that he has made available, then we can be confident in his working and trust in him with our lives. Right? So here's a quiz. Who or what am I? I will not submit to anyone else's instructions. I am rebellious. I will not cooperate and work together as a team. I am independent. I will not respect someone else's space. I am inconsiderate. I will strip others of their resources. I am competitive. I will start small, hide while I grow, and not manifest my true character until late in the game. I am subtle. I will spread to other areas and take over. I am aggressive. I will remove your loved ones from you. I am malicious. I will use more and more of your resources until you die. I am selfish. I am seeking to be immortal by my own rules, but in the end, I will die. I think that I am God and I demand everything for myself. I make others sick and weak. I cause them pain, and finally, I kill them. Get an idea of who this is? What is it? You, in your own mind, what do you think it is?
Cancer.
I am sin. Oh, that's right. That's what everybody's thinking, because that's the topic that we're talking about is cancer, right? I'm cancer, but I am sin. You see, cancer is a living illustration of sin. Cancer is a living illustration of sin. It is, in effect, the manifestation of the principles of sin in a physical way. Now, I'm not saying that everybody that has cancer, it's because they have sinned. But every cancer is because of sin. If it were not sin, there wouldn't be any cancer. There wouldn't be any disease at all, right? So it is the result of sin. But of all the diseases that are out there, all of the dysfunctions that are out there, cancer is the one, I think, that most clearly represents sin in a physical manner. It's quite interesting. And cancer, of course. We're looking at that too. I just wanted to take just a few minutes and I wanted to let you know about a few things that go on around here. Uchee Pines Institute, I don't know if you've gotten any background, I mean, we spent, almost a whole week together, and I don't know if we've said a lot about, Uchee and so on. Anybody recognize these guys? That's Agatha and Dr. Thrash. And let me just go here. I'm going to, yep. So they're the founders of Uchee Pines. And back in 1970, Uchee Pines began here on this property. Dr. Calvin was an internist, Dr. Agatha, a pathologist. She owned a few labs in the area, both of them trained at Vanderbilt University, and were doing quite well in Columbus, Georgia, until the Bible got a hold of them. And when it did, it turned their world upside down. And then also some individuals got a hold of them from Wildwood and taught them about natural remedies. And that really piqued Dr. Agatha's curiosity. And so she was a tremendous researcher. And so she started researching and reading and looking things up. And in days when there was not much information, you had to go to libraries, she was all over it. And they were constantly getting journal articles and looking up things and then began to write a lot of books about health. And she was a tremendous mentor for me and many others. Here's our lifestyle center. This is where we take care of individuals who come to our lifestyle center. And in fact, when I'm with you right now, let's see, I am sitting, there's my cursor, I'm sitting right here, right there, right inside that room. That's my office. And so I'm talking to you right now from there. And we are located here in Alabama, just on the Alabama-Georgia border, about central Alabama, almost on the border by Fort Benning. And in fact, sometimes you can hear the boom, boom, boom of the bombs and everything going off at Fort Benning and so on. And here is our lifestyle center from an aerial view. And again, there's my office right there. And I walk that way to go home, back off in the woods that way. It's a nice place to be. You can see why it's Uchee pines. All these are pine trees, pine trees, pine trees. We're surrounded by pines. And you can almost see him. That's our president, Louis Souza. And when you come in the building, here's our entryway. Gift shop is a lot more full now than it was in this particular picture. And here's our living room for our guests to hang out in. We have videos in the evenings that they can watch, and then stuff on the weekend as well. And this is our lecture room. So you were seeing some individuals giving their lectures live, or some of them with a Uchee background. They were doing that in this room. And you were looking at some hands-on nutrition classes as well. That was done right here in the back of the room. And this is where we have set up our section for the hands-on nutrition. Here's one of the guest rooms. This one happens to be carpeted. Some of them are not carpeted. And you come in and you've got closet space, and it's like a nice little hotel room, and recliners, and your own private bathroom, and so on. We've got the exercise room as well in case it's rainy and the inclement weather outside is not permitting. So there's stuff to do inside as well. And the favorite part of the program. That's where you get boiled, baked, fried, or fricasseed, or whatever it is. We also have medical missionary training programs for individuals who want to learn how to do this stuff, how to do hydrotherapy, massage, and use lifestyle and train individuals, and anatomy and physiology with common diseases, and biblical counseling and physiology of hydrotherapy and all that kind of stuff. Those programs can be found on our Uchee Pines channel, our website, and they learn all sorts of things along there. They're learning phlebotomy here. I think they're doing wilderness medicine here. They're doing patient evaluation and management, cardiology section, learning different heart sounds and other things like that. We also have our Country Life vegetarian food store and restaurant, right? So health food store and vegetarian restaurant. That is in downtown Columbus, Georgia. So across the river. And we are still operating, although the restaurant is doing takeout right now. Wow, that didn't work. That came behind everything else. All right, so anyway, so we've got a nice salad bar there and entrees, and then there's all sorts of healthcare products. And they also ship all around the place. And so if you want to get health food items and you can't find it elsewhere, then Country Life can get those for you and ship them to you wherever you're at, internationally as well. Our website, I would recommend that you go there and check out things. We have a lot of other resources other than just the virtual lifestyle session. Let's see, under health, under that tab of health, there's a section called counseling sheets. And counseling sheets, we have over 500 different counseling sheets on various different topics. Much of it natural remedies and things that you can do for various different conditions at home. So that's a good resource. Dr. Agatha put those together. We also have various seminars and events that happen off campus. Right now, everything's basically, shut down with this coronavirus thing, and so on. We also have under media, there should be a tab for our YouTube channel. We do have a YouTube channel, and so if you go to YouTube and you type in Uchee Pines Institute, you can find our channel. You can subscribe on there, and then when we have new videos and other things, then those will come out, and you can watch those. And we have a number of different series. We've got different playlists. If you want to see my Law of Life series from the past, you can go there. Other things, if you're interested in more information on diabetes, hypertension, high cholesterol, cancer, other topics and whatever, we've got, I don't know, probably a couple hundred videos that are here on our YouTube channel that you can access. And then, of course, the virtual session, you're involved in that right now. Just want to let you know, we will be starting, well, there will be another 6-day, just like this one, that will begin on May 17th. So there'll be another 6-day one just like this one that will begin on May 17th. So if you have friends and family that you think would benefit from this, if you have and you think they would as well, then let them know. Again, it's only 20 bucks. It's a steal. we're yeah, it really is. And then after that, on the 31st, we're going to begin our first 17-day virtual sessions. We're going to start our virtual lifestyle sessions, our 17-day. This 17-day is going to be quite different than these 6-day ones. The 6-day ones are heavy on group interactions, like right now, live events and whatever with the whole group and so on. The 17-day ones, most everything that would be done in a group setting is going to be pre-recorded. So the presentations and all of that kind of stuff are going to be pre-recorded. The lectures and whatever are pre-recorded. Live things will be things like the welcome, the orientation, and so on. Morning walks in the mornings, and then a farewell meeting. But a major portion of the 17-day program is that those that are enrolled in the 17-day program, you will have up to 2 hours a day of one-on-one face time through Zoom with a lifestyle counselor who will help you troubleshoot your particular situation at home and how can you apply this and how do you implement these things and so on. Plus, you'll have at least twice a week appointments with your lifestyle provider, myself, Ashwin, Adan, Oyinka, the others that you have seen, Shanice, and so on. So with your lifestyle providers, you'll have appointments with them at least a couple times a week. That will be at least a half an hour, maybe up to an hour with the providers during those visits. And so what we would end up doing is putting together a specialized lifestyle plan for you based upon what your condition and so on and so forth is. And then the lifestyle counselors will be there on a daily basis to help you implement, to walk you through how to do those things at home and so on and so forth. What we're trying to do is we're trying to provide our lifestyle session and get it out there in the virtual environment. So what will be the pre-recorded videos will actually be the lectures and the things, worships and other things like that we do for our actual sessions here at the Lifestyle Center. And so we're trying to take that and put it out there. Now, it is very intense. You're looking at about, I don't know, 6 or 8 hours of either videos and or face-to-face time with individuals on a daily basis through the week. So it is very intense, and so this is for individuals that are not planning on doing work and doing this at the same time. It's for individuals that they've got health challenges, or they're very interested in getting their health under control and they're going to take time off of work. Of course, a lot of people are quarantined right now. Who knows what the quarantines will look like by the end of May, beginning of June, and going on from there. But that's something that's available as well. That will be $999. That'll be $999, which is actually a really good rate. Our sessions, if you come here, live with us, be with us for a 17-day session, eat with us, do the treatments, all of that kind of stuff, it's $50 to $45 or something like that, somewhere in that range. So $999 is a significant discount. And if you're doing that and you decide, hey, I actually want to come to Uchee and do a session there so that you can do the treatments on me, I can eat the food that you're preparing, I can actually, instead of you trying to walk me through that environment, I want to be in it so I can see how it all works, then what we would do is give you about $500 off of your virtual session and put that towards your regular lifestyle session. So those are some things that are coming up and that we're planning for. Let me stop recording now, and then we'll do questions.